So yeah, it's not always fun when you're the guy standing between people and their lunch. But and I also realize over time that in the battle between stomach and brain, stomach always wins. So I'll try to keep this brief and at least get you some key insights that could hopefully help you in your organizations as well. Um, so I'll give a quick introduction to Rakuten, and this is important because the scale at which we run our businesses, our products, and services. If you don't have that context, it's hard to sort of relate to the data and AI initiatives that we do, at Rakuten, and because it's a very, very broad and diverse set of things that we do at Rakuten from data and AI perspective. So, very large company, about $140 billion in sales just last year. We have about 1.3 billion users globally, about 200 to 250 in e-commerce and retail, and the rest billion or so with Viber, which is one of the largest messaging platforms in the world. 100,000 plus merchants. We have about 70 plus businesses and services. I'll give you a quick preview later. And revenue grows around 17% year over year. This is the subset of services that Rakuten has globally. We are in everything from e-commerce, payments, credit cards. We have our own credit card, our own bank. We have our own hotels. We are in the travel business. We have a marketing and ads business. We recently started a mobile network business. I'll talk a little bit about it later. We are into energy trading. We are into securities, stocks, mutual funds, and so on. We have our own coffee shops all over Japan. We are headquartered in Japan, but we are in over 50 to 60 countries, globally. Our strategy is all around, our brand, the membership that we have, 1 billion users, and the data we have about users, right? I mean, this cocktail comes together so well for us, both in terms of engaging our users, and about 80% of our users, customer base in Japan, which is about 100 million plus, uses at least one or two Rakuten service, and that comes together because of this fantastic membership point program that we have, where we give out, super points. There's cashback. There's other ways that we engage our users. And it sort of creates this beautiful ecosystem, which also is a fantastic exit barrier, for us, or because consumers continue to stay within our platform. This is just sort of a small example of what happens when you have cross-use of services, right? If let's say the lifetime value of a user is 1, when they're using one service, by the time they use just 2 services, in this particular case, Rakuten Ichiba is our e-commerce platform in Japan. And once they come in, they get points, they start using it on our travel business, and then they perhaps, get introduced to our books business. The lifetime value of a consumer goes up 6x, right? Just by having 2 to 3 services, let alone 60, right? So that's the power of the ecosystem that we have. Just to give a very high sample, we are number 1 in e-commerce, credit card. We are second in travel, first in payments. We have, first in banking, and top 3 in equities trading in Japan, right? And that's how big we are in terms of our reach and scale. And as I mentioned before, to add to the diversity of what we do, we are starting our own mobile network, similar to Geo in Japan. But this is going to go global, and the reason it's going to go global is we are doing it very, very differently. This is not your 10-year-old, network architecture with dedicated hardware. This is a completely cloud-based, virtualized network. All we need is blind antennas, or actually dumb antennas, that are going to be put all over location, whether it's Japan or any country, and all the intelligence, whether it's call processing, traffic management, security, operations, all happens in our private cloud that we have built. So the plan for us is, once this is going to go live Q1 of next year. We're already in trials, and we are the first 5G operator, getting about 10x the scale of speed and scale of 4G as well. And the reason this blends into our strategies, if you look at how Reliance is attacking the market in India, right? I mean, they built the network first, and then they've got entertainment, and now they're building e-commerce on top, and sort of the stack comes together and builds their verticalized ecosystem. We are going it the opposite way, right? I mean, we have a well-entrenched e-commerce, payments, infrastructure and ecosystem in place. We are going down the stack, And then once you have your mobile network in, there's really no reason for the consumer to leave your ecosystem, right? I mean, the whole strategy is anything that a consumer does in their daily life, from buying things to eating food, to going somewhere, to calling someone, to messaging somebody else, everything happens on our ecosystem because we pretty much have all the services a user needs at any point of time, right? So this is an introduction to our scale. Now we'll get into data and AI. Be ready for the math, and you might also now regret why you dropped out of that statistics class in your high school. I'm just kidding. Before I get into that, we also not only own sport teams ourselves. We own Rakuten Eagles, in Japan. We are also the official sponsor of FC Barcelona. If you must have seen Messi and his team play, they have Rakuten is our official sponsor, right? We have a 200 million investment, euro investment in that. We are also the official partner of Golden State Warriors and the Spartan race as well. So this helps us scale internationally from 20, 30 countries to about 60, 70 countries that we are in. Now, let me sort of get into the idea for the next few slides. I'll touch upon each of those. I won't really get into the deep technology or the math behind it. Is given the span of our business, we have to work. This is table stakes for us. This is not an aspiration. This is not out there. Data and AI is what we do on a day-to-day basis on pretty much everything we touch, right? From cognitive computing, predictive analytics, statistics. We have tens of petabytes of data, generated by these 1 billion users globally. That gives us insights into users' behavior, their needs across our platform, and we use this data to solve some really complicated problems, right? Just a sample example. I have about 10 to 14 different examples that will give you a sense, and hopefully some of these can be takeaways to you guys as you attack problems in your business as well, right? Product science. We have about 20 million catalogs that are on our business, right? About 8 million just in marketplace. Merchants come in, they start putting catalogs and pumping and dumping on our system. That could be a wine bottle that's up there. The data is not going to be clean, right? They're going to come in, put it in a very different category. Some guy puts it in grocery, another guy in food, someone else in wines, someone else in party memorabilia. Now all of that is going to have a function on search, right? Your search engine is going to get confused if you have these many different categories. What happens if the search engine gets confused? The right product won't show up when the consumer comes and search. That has implications to conversions, to business, to GMV, and so on. So a lot of the work we do in AI and data is all about automatic categorization, right? You can't tell a merchant, hey, go and put it in this category, so on and so forth. We look at the categorization. We put it in the appropriate category. If there is description or images that's not good enough, we go and autofill it because we have access to a lot of similar quality description across our 10 million catalog, right? We extract and do it. We clean up images. There's going to be merchant is not one person, right? Merchant is like 100,000 people in different categories of the economic sphere. Someone might be putting up images with their mobile phone and putting it on our website. If the image is not clean, the customer is not going to spend time on the product view page looking or engaging with the product. So we use deep learning and some of the algorithms there, like convolutional neural networks, to clean up the image and produce a very high quality image on the system. So some pretty sophisticated work goes on into that. Secondly, building customer model, right? As I mentioned before, we have very different, peek into the consumer's behavior, with their purchase history, their click-through data, their search history, their attributes, right? In many cases, over time, we know sort of how much can they afford, what do they buy, and so on and so forth. So we build a customer model. And what this helps us in is, let's assume you have a business guy in your commerce organization who wants to sell the last 100,000 sneakers that they have in the portfolio, right? How do they know whom to target? They're going to come in and ask the data team and say, hey, look, give me a cohort of people who are going to buy these sneakers in the next 48 hours, right? So that's where this cohort analysis comes in, right? We're going to find 100,000 similar looking users to the one the business guy wants to target. And then they're going to get that subset of users. In fact, we are externalizing this as well. For example, a Toyota might come and say, could you give us about 20,000 of your customers that are willing to buy a Camry or an Innova in the next 2 months, right? But we would have built a user profile based on years of their behavior on our platform, so we can give them a prospect list much better than they themselves can find. So those are areas of monetization as well. I won't go to this. The bottom one is more around recommendation. Recommendation engines have been there for a while. Everything from adaptive filtering to multiple techniques are used. But what's interesting is similar examples, right? You're a business person. You have got, let's say, $20,000 in your budget to increase sales, right? Do you just blindly send out coupons to every customer, or do you send it to the ones that are the most available to buy those coupons or make use of those coupons, right? So prospecting or optimizing coupons, because this is real money. I don't want to burn my $20,000. I want to burn it on the right guys who are going to use this. There's a lot of machine learning that goes on there on who is best suited to use these coupons. Geolocation user analysis. So this is another area, right? Rakuten is not just online. We are into offline as well, right? We would love to send our customers to offline stores because chances are 80% of them are going to use our credit card and our payment to buy things. So they don't necessarily have to buy things on our online store. So what we do is we look at users' location in terms of where all they've been. Where are they shopping offline? And we again get their persona offline as well, right? And this offline persona helps us to, let's say, send them recommendation for a stop very close to where they are, or maybe try a new shop, right? And maybe they're a connoisseur of wine, they love football, whatever it is, or fashion, jewelry, and so on. That's one thing. Very interestingly, we also have an online platform for horse racing, which is perfectly legal in Japan. And again, based on a user, how long they've spent in a horse racing stadium, we know what's going on there. So we sort of send them promotions in terms of here's a new race coming up. We have a bidding platform. We might send them some promotion and so on and so forth. So again, we know what the customer is doing online, offline, whatever it takes, right, to help them along their journey. Fraud is a part of life. Now, it might be probably the country with the least fraud is Japan, just based on the culture of the people and and the way they look about and the social norms and values. But when we go operate in these many countries, every country has a very different type of fraud that happens. Some of the fraud that we solve with AI is it could be anything from massive logins from a specific IP. Someone is doing account takeover, right, of users. So we can, we look at things like what has been the average statistic, of traffic from these particular regions, and anything that goes beyond that, we know something is going on, right? So we start blocking and, taking a deeper look into what's happening there. Fake reviews, right? New merchant comes in, wants to trash the competitive merchant or put them down in the ranking, gives fake reviews on a competitor products. We have to solve for it. As an independent platform, we have to be fair to everybody. Again, we use machine learning and AI to look at automatically, and you can't do it manually. I mean, we probably have 10 million reviews on a weekly basis going up on our website, right? I mean, this is all, we are using NLP to go look at keywords that indicate patterns, keywords that indicate this is fraudulent review, and we continuously go on and take these things out. The other thing to about AI, right, is that you're not going to get a 100% solution, and frankly, there is no need for one, right? All you need to do is continue to elevate and up-level the state from A to B, where B is in a more positive direction, right? If I have 70% less fake reviews on my platform tomorrow than what I have today, that's still a good place to be, right? And that's how algorithms evolve, right? State-of-the-art AI algorithms continue to evolve. I mean, these days we use thing called multimodal learning, which is very, very sophisticated. Because when you look at just language, text, video, and so on and so forth, each has its own machine learning and AI discipline. Multimodal learning brings all of these things together, and it's about as complex as AI can even get, right? So those are some of the things we put in. Even credit card fraud, right? We are now in Taiwan. We are going to be launching in Europe and US. We look at all the data to look for fraudulent activities. Did someone make a huge purchase suddenly, right? Or was this card used yesterday in Singapore and day after, tomorrow in Rio de Janeiro? All of those activities we look at to see whether it's fraud, and then we take action. Fake products, right? And in fact, when I was at Flipkart before this role, one of the biggest challenges in India was fake products, right? Someone is selling let's say, Kanjivaram saris, in a merchant has put it up. Some other merchant from Surat comes and attaches himself or herself to that particular listing, but you know that it's, and then they sell 50% mixed cotton and silk sari, right? How will you solve for this? You just have to look at previous patterns. In this particular category, from this IP address, from this location, who has logged in before? Is this a risk category or not? Has this been consistently been done? Is there a pricing differential between the two, right? Again, it's all machine learning happening in the background, because how will you solve for fake products at 10, 20 million product listing scale? We do a lot of things, data and AI in financial. We are into, like I said, stock brokering and securities, right? Rate optimization algorithms, help us fulfill, orders, right? There is all kinds of trading going on. Algorithmic trading, the small guy is trading. People are taking to take advantage of micro movements in stock prices. So we look at sort of, how do we solve for optimizing some of those sales? We do risk hedging as well, right? For some of our investors who want to buy in a particular category, the mesh system comes in and says, hey, look, you're putting in your beta is too high on this. You need to hedge this. Here are some investments that will help you hedge the bets. Credit card, there are a lot of startups in India today who are looking into building credit modeling, right? We have been doing credit modeling for almost a decade now, right? We have insurance businesses, we have lending, we have banking businesses for over a decade. And the algorithms have gotten pretty status quo in terms of, hey, look, we know this user's behavior on our platform. These are the things they buy. They spend about, let's say, $10,000 on a yearly basis on our platform. They use our credit card, they pay on time, they pay every month, no issues. There has been no instance of fraud or fake or returns, or unnecessary returns that have been tagged on this user, completely legit. Once that signal goes to our bank, which is our own bank, the loan gets approved in 10, 20 seconds. Right? That's the power of data, and that's the power of AI happening in real time. Machine translation. Sure, there is Google Translate, but we have a streaming business, right? We have a business called Rakuten Wiki, which is Korean content that's actually pretty, has dozens, millions of consumers in Asia, right? Korea, China, Taiwan, and so on. Even in India, interestingly, people love to watch. We have 500,000 users who watch Korean content, whether because they love Korean content, Korean comedy. The automatic language translation, I don't know if you guys have seen, even Google on YouTube, if you have seen some of the English translations, it's pretty funny, right? They are fantastic at text translation, right? They're probably world-class there. But video translation of real-time content, Rakuten we have had phenomenal success, right? I would say probably the quality of our content translation has 90% success rate, from Korean content to English. And similarly, we do for 35 different languages. And video content translation is a lot more complicated, right? Because every scene is going to be different. But where AI comes in is it narrows down on emotions. We even tag things like, the reason why this translation is not good is because the emotion of the moment was anger, but this has translated into something that's really funny, right? So the AI is matching it in real time, and there's a feedback loop that goes in to say whether this was good or not. So we continuously improve. Logistics, again, we have warehouses all over. We have trucks, we have drivers, particularly on the left, right? We do things like route optimization. Our use cases are pretty unique in that a user in Japan might say, hey, they're just going to use Viber and tell our customer support, hey, look, I had asked for this delivery at 6:30 p.m., but I am stuck at work, so I'll be home by 7:30. Can you delay my delivery by an hour? Now, you can't solve for this without deep AI, right? Because it's looking at where is the truck going, what direction, what is the demand there, what's the delivery for today? Is this user near to the zip code? Is there some other delivery I can do and reroute in real time? So there's a whole lot of stuff that goes on that gets, and the reason this AI is important because it delivers a superior user experience. We are not doing it because it's cool to do it, but because this elevates our user experience. We're also doing some pretty cutting edge stuff in terms of unmanned delivery robots, right? End of the day, if you look for things like, particularly in Japan and US, the people who are doing delivery, they tend to be older. People who are 70 plus, they are delivering. They can't take up heavy stuff from the truck and go deliver it to the user, particularly if they're on the 30th floor. So we have delivery robots that pick up the product from the delivery truck, put it on their back, and it actually goes all the way over to the elevator, rings the bell itself, and goes up to the 30th floor, delivers the product, to the door, right? I mean, this is not production yet, but let's say it's pretty much in alpha stage. We also do drone delivery. Again, that's a whole new ballgame completely by itself. It's three-dimensional modeling, traffic, so on and so forth. Computer vision, I mentioned to you before, a lot of things unique to Rakuten, right? Let's say we have images of a shoe, we have text, we have styles. We want to generate a banner, we want to generate an ad. Now, people who are in the business of generating ads, their business is already in threat because of some of the things that we do, right? Here, AI is generating the ad by itself. We don't no longer need to go to an ad creator or a banner creator. All we need to say is, I'm going to type in and say, hey, show me something cool with a Japanese model or a Chinese model wearing a red-colored Nike sneaker with a beach in the background, right? I'm just going to type it out, and boom, that ad is up already on our website. The intent of this was not to take away the jobs of an ad developer, but because at scale, how do you even do it, right? 100,000 merchants want to build 500,000 ads. You can't go around paying people to do all of this. I mentioned to you before, image cleanup, right? The croissant there, we have this algorithm called super resolution. It just takes almost all of our images and takes it up a couple of notches, whether it's the lighting, whether it's exposure, cleaning up of things on the table that were not supposed to be there, all done automatically by our AI machine. This is an example of ID fraud, right? What happens is we do face-based payments, and a lot of times what happens is someone takes a picture of you, and they're going to use your picture in your mobile phone and try to authenticate it, right? And this, by the way, in China and Taiwan, this happens on a daily basis. So our deep learning system recognizes that this is a 2D image or video being shown on a phone, and it solves for this. So this is a fraud that we have already solved for as of a couple of months ago. But Chinese hackers have gotten even more sophisticated. So what they're doing is they're creating a 3D model of your face, right? And they're keeping the 3D model to solve for it. So the scientists that were actually in our Bangalore center, we have a center for AI and image recognition. They are now solving for 3D fraud as well. So we have to keep upping the ante on a daily basis. And like I said, this is not some cool thing we do. This is thing we have to do to keep up our current business. Couple of other things. We have a live Rakuten Live, right? Which is like Facebook Live. We stream live events, whether it's music concerts or a celebrity event and so on and so forth. How do you solve for inappropriate content, right? And this is the hardest computer vision problem we have come across, because this is real-time data, right? You don't have the luxury of storing this on your server, and a scientist runs their CNN algorithm at their convenience over the weekend. This is happening live. How do you catch this? Text, voice, and image and video, right? Some very, very interesting things we have done. We've reached, like I said, we've reached about 90 to 95 percentile accuracy on this, where we catch all of this. 100% is never going to happen. But as I said before, 95% is better than 0%. And that's keeps all of our consumers and youngsters on our platform pretty safe. I'm going to skip through this bit. A lot of AR, VR stuff that we're doing, particularly around, can I get additional information about, let's say that particular Coca-Cola can someone is holding, right? We have apps that we look at the can and it's going to give calorie content. It might say things like, hey, you might get cheaper on Rakuten. Of course, the offline guy won't like it. But that's some of the things that we do with respect to AR. And last two things I want to talk about, and this is somewhere we are diversifying into right now. And this work happens all over in our Rakuten India office. We are getting into cancer detection and care. The first one is about cancer detection. Now, cancer detection, of course, your doctor is going to pick it up in an MRI. But there are going to be such tiny, beginning stage tumors that even a trained surgeon may not be able to pick it up. Right? Some of the things that we have done that we are now in collaboration with hospitals to productionalize, is our AI has been able to detect potential, tumors that can potentially turn into cancer. What happens is you're looking at hundreds of thousands of images. So over time, and you have to feed the system data 3 years ago and data 3 years later. So it has a pretty deeper sense of what could turn into cancer, right? And so it's used as a physician or a neuroscientist or a neurosurgeon's aid to help detect cancer. And this one, lastly, I want to end with this. I mean, this is the most revolutionary care and technology in cancer that I've ever seen so far, right? And the system is called photoimmune therapy. Many of you may have been aware of it. We have actually 2 Nobel laureates in biotechnology in our company who were awarded the Nobel laureate for immunotherapy. So the way photoimmunotherapy works is instead of, and I'm not a cancer expert, so I'm just going to sort of give you the very high level understanding that I have about this technology is, when you go into chemo and radiation and so on, it targets a pretty broad swath of the organ that's affected by cancer. So what immunotherapy does is, we actually put in a marker and we inject it into the human body. And it goes and latches on to almost all organs, just like chemo does. But with photoimmune therapy, when you actually draw a photo light, when you focus a photo light on the particular organ, in this case head and neck cancer that has cancer, it activates the immune cells of the human body in that particular spot, not all over your body. So the immune cells, the T cells, the killer cells actually go and kill cancer in that particular area. This is right now in phase 2 trials, and we have tried it on almost, let's say 200 plus patients. And the ones for who this immune therapy has worked, the cancer is completely cured with pretty much 0 to 5% side effects. So if there's one technology to bet on for the next 20, 30 years, it's photoimmune therapy, right? What we do in terms of data and AI is, particularly the team that we have in India, is when you inject this particular anti-cancer medication, there are some biomarkers that your body shows, which says the probability of this person getting cured is, let's say, 80 to 90%. So we can then select this person and do way more advanced trials. And when we look at things like, it's very, very interesting when we show the video, we can't show it right now, but the video actually shows that once photoimmunotherapy starts, the killer cells, the T cells, human body, just starts, which was just sort of coasting along, oblivious to the cancer cell, suddenly starts coming, attacking the cancer cells. And so we look at things like the distance between the killer cell and the cancer cell shows how effective photoimmune therapy is on this individual, right? And that's a lot of advanced statistics and machine learning, which your bioscientists working in your company are not going to have, right? I mean, they're biologists, scientists. So you match machine learning experts, statisticians with biology, and something amazing is going to come out of this. Honestly, I had tears in my eyes when I saw this person completely cured of cancer. That cancer cells over there in the head and neck looks like this after the treatment, right? I mean, so that is the potential, and so this is part of our diversity. And I'm really happy that AI and machine learning has reached a stage where the sample of applications that I've shown here is probably 20% of the kind of things that we do in our company, right? To scale our business, to provide value to our users, and to society as well. That's all I had. Thank you for your time.